Okay, hello everyone and welcome to our atom visualization presentation. I'm sure this might not mean much to you guys, but to us, I'm just kidding. You guys are all here to listen and I really appreciate that. Thank you Maria for introducing us. This is a project we've worked really hard on for the last 6 months around, so we're excited to present this to you guys. So, what are we looking at? Can someone tell me? This is rhetorical because I know a few people can answer me actually, but I'm sure the majority of you guys don't know what the heck this is. I don't even know what it is, I'll be honest guys. I just searched up complex molecules. I think this one is like one of the most complex molecules, but this has a question that needs to be answered. What are in these molecules? Well, in these molecules, there's atoms. And what's in an atom? I also don't know, guys. That's not within the scope of this project. But a very important thing to understand is that atoms are what make life. And in order to understand a lot of concepts that are taught in biology classes, you need to understand the core mechanics of life, which are atoms. So a lot of issues that students at Bellevue College go through, especially in the introductory biology classes, is that they don't understand or have the fundamental atomic knowledge that they need to understand the rest of the course. So what our project aims to do is to give students an additional resource to learn more about atoms. So here is our atom visualization program. So this is a VR program that combines atoms with VR. So students will be able to look at atoms in a 3D manner. They'll be able to manipulate them, move them around, they'll be able to play with them, and they'll be able to participate in a few simulations that would kind of help them understand real-world scenarios. And this would be used in tandem with existing resources. I know for a lot of people it's kind of hard to understand atoms because these are all 2D resources and it's kind of hard to visualize them in a 3D manner, and in real life atoms are, these 3D things. They're not just pictures in a book. So yeah, this could be used with textbooks and simulation games or videos, etc. So how did we even start? Let's introduce ourselves. So my name is Sophia. I am the project manager and I was the documentation lead for this team.
I'm Joshua. I was the developer.
And I'm Angel. I was a 3D artist.
So last quarter we also had a 3D artist and UI UX designer. Her name is Katerina. Although she was not here with us this quarter, last quarter she did provide us with a lot of work, and I will say what she did during the live demo. But so every sprint was 1 week during the first quarter and 2 weeks during the second quarter. But every sprint we kind of went through this agile framework where we had our requirements and then we designed around that, and then we started developing, and then we started testing using user testers, survey testing, A/B testing. So this just means that we're giving people many options to choose from during our surveys or during our usability tests, and then we would deploy this and review it. So sometimes we would actually keep testing people for the same things, and we would keep changing it until nobody said anything about it anymore. Because if something sticks out like a sore thumb, we have to look at that because that might be something we need to fix. And so here's just a screenshot from one of our sprints. We just have a bunch of tasks here, and we just kind of kept track of that throughout the week. So let's talk user research. I kind of talked about our agile framework. So user testers, we had full usability tests. So the user testers that would be testing our program would just run through the program, and anything that they had to say, they would tell us, whether it was, this is too hard to understand, or this atom is too small, I can't see it, anything like that. And so for A/B testing, we did a lot of that with user testers, but also with surveys. We would give people many options to choose from, and they would choose what they thought was like best for them, or what they thought might be best in a program, in our program at least. And so we would just kind of keep going through that like a cycle. And so project evolution and important iterations. Our first pivot in direction was actually, do we do this in AR or do we do this in VR? So for people who don't know what AR is, it's augmented reality. So you can kind of see this, like for example, like if you use your phone will be able to display like 3D images in your like physical reality. And VR is the project that we ended up going with, or the method that we ended up going with, because we had a lot of constraints. Some of it was our experience, and we understood that we would get more feedback, and we had more resources if we decided to go along with this program in VR. And we knew that the students at Bellevue College, who we were making this for, would have access to this XR lab. So we thought it might have been more appropriate to work in VR. And so we had 4 different types of user feedback. We had interaction cues, scientific accuracy, usability and accessibility, and understanding. So all of our users kind of had something to say in the realm of these 4 things. If you guys don't understand my examples, don't worry, I will touch up on that during the live demo. But for example, for the interaction cues, the feedback we got, we ended up adding sound effects, haptics, and visual feedback, so the user understood that they were actually doing things in the program and they were getting feedback, for example, like clicking a button or getting something correct. So for scientific accuracy, an example would be, so in an atom, there is an order to the population of electrons in the electron simulator. So at first, we kind of had it where the user would be able to put stuff where they wanted, and as long as they got the amount of electrons there correct, then it didn't matter, they got it right. But actually in a more accurate manner of showing that is that they have to populate, you know, 1 shell at a time, so we changed that. As for usability and accessibility, we added a start and stop button for users in the electron simulation, so it's easier to populate electrons. In the live demo, you'll see that these shells are constantly spinning, so having a start and stop button was really helpful for a lot of people. And understanding, so we added a tutorial section where users should be able to go through the whole program with very comprehensive instructions so that they're not left asking questions after the tutorial, or at least I hope not many questions. Biggest challenges and key learnings. Guys, if Murphy's Law has taught me anything, it's that anything that can go wrong will go wrong. But we were prepared. The big challenges were, you know, our lack of experience, you know, our lack of scientific knowledge, and our schedule differences. Like, how do we mitigate that? Like, how do we set realistic expectations for our client and for our users, you know, despite our lack of understanding? So a lot of what we did was we consulted with our developer, we understood what was possible and what might not be possible, and we set our scope accordingly. We even underscoped at some points so that we could give room to either grow or to just have more cushion to work on certain aspects of the project. And sometimes when things didn't work out, that's totally okay. We just moved the goalpost. And sometimes you guys just have to move the goalpost to make things work out. And it's a very appropriate thing to do sometimes. As for scientific knowledge, like, how do we maintain accuracy when none of us on the team really were that knowledgeable about like chemistry or atoms? Well, I took it upon myself to learn a lot about atoms and chemistry, but because of the help from Heidi, we got in contact with biology and chemistry professor Christopher Shelley, so I was able to talk with him a lot and make sure our program was as accurate as it could possibly be for what we wanted to do, at least. And scheduling differences, we just had to communicate. If everyone couldn't make it to a meeting, we just had to let our group know what happened, take some meeting minutes, and just have some conversation with them about what they thought, how we could proceed from these meetings. And for communication, I'll be honest, all of us did great at communicating, so I put a picture of a cat because a really good thing to do in your team is to understand everyone, know where they're coming from, know what they're going through, just share funny cat pictures with each other, just become friends with each other, and it'll make communicating a lot more easier to do. So, I think we're gonna do our live demo now. Okay, so we're gonna run through the tutorial for atom visualization because it's actually encompasses a lot of what we worked on. It's condensed into this tutorial.
So basically, we have just text explaining what happens, a stop/start button that Sophia explained, to basically stop the atoms so you can kind of count them. This simulation is basically to review knowledge and to see, like, for example, how many electrons are in each shell. You can grab it and just see, yeah, you can grab it, interact with it, distance grab, that sort of stuff. And that's it for this simulation. Very basic, but yeah, as you can see, this one, it changed a lot throughout the process. I don't know if you can see this, sorry.
Yes.
Yes.
Okay, but essentially, like Sophia said, it used to just be like, there were several shells here. You could place these electrons into them in any order, and it would just work. But now we have only one shell, and then you press the check button, and then a second one appears, and then you can populate it. And as you saw in the previous sim, carbon only has two in the first, 4 in the outer, and then after pressing check, the next button appears. Oh yeah, and you can also stop/start this. This is the model scene. So basically what you can do in this one, you can still distance grab, but essentially you can select different bonds and then drag the atoms into the boxes, and then and then and then an animation will play. A blob will appear just showing.
Yeah, like the polarity.
Yeah.
So this is a non-polar bond.
Yeah. And then, yeah, the next button appears for this one. In the main scene, you can do different ones like CH4, H2O, NaCl, those sort of things.
And those are more core molecules that students need to understand how they're created. So that's why we chose those.
And then finally, the dissolving sim, which basically shows how salt dissolves in water. Basically, if you grab these water molecules, you bring the negative charge to the positive charge, and you do that for 3 of them. Hitbox is a little small. You can just drag these away to basically show that when the water kind of attracts to this, it pulls it away from the bond of NaCl. So as you can see, the sodium, Na, it gets pulled away from the Cl, or chlorine. And you can just do this here. And that's it for the tutorial.
So, you guys saw how this program works. It wasn't the whole program, so how can you access this program? Well, we have a QR code, and this leads to the open education resource that we recently published. And so you'll be able to get a complete summary of how to access this project, our documentation, and our GitHub repository. We really believe in having this project be an open education resource, which means anyone will be able to access it change it however they like. We have all of the documentation and even the source code for it that people will be able to access. So here's the project summary and an access to the program. So just briefly, we have all our programs on the MetaQuest, and we have a small installation guide, and we have our GitHub, which is where our source code is. So anyone will be able to access this project and change it how they see fit. As for documentation, we have everything on a Notion. So if anyone is interested and wants to access this, we have our problem statement, project summary, and we have a lot of resources, and we have all our roles and our project overview with a few videos that go along with this. And we also have our project trailer, so if you want to check that out, it'll be on the open education resource for everyone to see. And so special thanks to, I just wanted to say, special thanks to Heidi for even having this project for us to do. I really believe in educational resources, and our whole team worked really hard on this project. And another special thanks to Christopher and Cameron. They helped us ensure that this project went as smoothly as possible regarding scientific accuracy and advice on our implementation on the Unity program where we made this program. And we have 4 named user testers. We had a lot of other user testers that we didn't work super closely with, but they still had a lot of valuable advice to give. And so for our Q&A portion, we just wanted to play this video in the background while we answer your questions, so you guys can just see what the rest of the program might be about. And that's it, yeah. Any questions?
I'm curious how anyone could become a tester. How do you get that?
How do you access this program?
No, how could you credited a bunch of people for testing?
Yeah.
Do you have that along the way? Do you have a need for those people? And I'm volunteering. Yeah.
Well, yeah. I mean, we don't know what the future of this project will hold, but if we keep working on this, we can have. We always need user testers, and especially the user testers that we need would be like students studying chemistry or people who have VR knowledge that can tell us more about how they intuitively interact with VR programs. But if this project is going to be worked on in the future, I'll have my contact in the Notion document, specifically like asking for user testers if we need them.
Can you explain the game? Do you have to catch the atom and then you name the atom? How do you know what atom the one that you caught is? Do you have a name relationship with the atom or the composition of the atom, or I don't know, what is he creating there, for example? Do you have names, or how can people learn with your game?
So in this section, our model section, we have 7 atoms people can choose from. So it's listed in these boxes what the atoms are, and it has an accompanying label with it. So for example, if you chose sodium, which is what's chosen right there, it has an Na, and it says, it has the symbol right there next to the name. So you don't catch the atoms, you can choose them from the menu, and you'll be seeing the same atoms and interacting with the same atoms throughout the whole program, so you won't, this program is meant to be played in steps. So this would be the first one. You would just look at them and count the electrons and just see,
and then you know, okay, that many electrons is
Yeah.
that atom.
Yeah, so
That
then
many.
in the next simulation, you have the electron simulation where you need to test that knowledge and actually put how many
Oh.
electrons you think are in the atom, but you learn this over here.
I see. Okay.
Yeah.
That is useful. That is a big part of the project to learn about the atom.
Yeah.
I have one question. So this is C# Unity. So how many lines of code approximately, and how long did it take to write the whole thing?
For each sim, there's several different scripts. Like for example, for this one, you kind of have to make it so that you buy buttons here. Like this one didn't take too much time. It's really, the long ones are really in the last two parts, the dissolving sim and the molecule sim. I believe the longest script is around 300 to 400 lines of code. But that's just from kind of just like, because there's different checks that I have to do, and it's mostly just from doing those different checks that the length of the code arises.
Okay. How long approximately did it take to write the whole thing? All the scripts?
All the scripts, approximately how long? I don't know the exact time.
Like 5 months.
5 months?
5 months.
Around 5 months for the entire program, but if I were to put it into just hours,
Yeah.
I'd say at least over 30.
I think more than that.
At least 2 hours.
Yeah. And just you were new to Unity, right?
Yeah.
Like and C#.
Yeah.
So yeah, very impressive.
Good job.
Thank you.
Yeah. Cool. Thank you so much. Do you have any other questions? No?
I just have a quick
Okay, Bruce.
Yeah, I'm just curious, it kind of relates to an earlier question. How is Heidi going to be using this within her course? How is that, what are her plans for this? And will she be part of just guiding students into this process?
We actually personally don't know her plans, if she wanted to, sadly she already left, but we don't know if she wanted to directly incorporate this into her curriculum or if this would be an additional resources that she could link students to access on their own free time if they needed that kind of help. But we'll talk to her about it and see what her plans are with it.
We actually have 2 more questions in the chat. We try to make it short because
Yeah, of course.
we're running out of time. But the first one is like, knowing what you know about this development process, working on this project, what, if anything, would you do differently?
Probably learn more about coding and then applying what I've learned to this, because there was a lot of different roadblocks that I needed to figure out, and I don't know if I did those in the best way possible. So learning more about coding would definitely be helpful and is something I do differently, just coming into this with more experience with Unity.
Yeah, and the second one is, what better practices will you bring to your next teams and projects that are a result of learning of teamwork for this project and working with the client?
As a project manager, what I would bring into future projects would be more, I want to update our client a lot more. It was, sometimes our project went in very unclear directions, and I think that we could have consulted our client more than we did, and so I think that's a skill that I would take onto my next project if I had to interact with our clients again. I don't know if you guys had anything you take.
I honestly agree with that, because
Yeah.
at first we didn't really communicate with the client too much, which was a big problem, but aside from that, I'd probably take like my experiences with communicating with the team into future projects, because this turned out really well for our current experiences with everything. And I think I owe that to like all the communication we did, all the, and just everything.
Thank you.
Back,